All right, so we are going to do kind of what I mentioned to you guys yesterday. We're going, oh hey, welcome back.
I'm back.
We're going to get started on section 3 of chapter 9. This is our last section, like the last section of actual new material for the entire year, okay? But like the directions tell you guys here, we're gonna do day 1. It says of at least 3 or 4. In reality, it's probably more like 4 or 5. Like I anticipate next Wednesday being probably the first day that we could even conceivably think that we're gonna be done with this section. There is a wealth of information in this section. There's just tons and tons of material in it. The nice thing for today is we're gonna keep it very, very straightforward, very, very simple. Today is gonna be the easy day. Even Monday, I think, is gonna be relatively easy. It's not until we get to next Tuesday that you're really gonna get kind of bombarded with like the introduction to the advanced math side of this, okay? And we just scraped the surface of what advanced math is doing, okay? We don't go very far into it whatsoever. So, like I said, we're gonna have one definition. I'm gonna translate that definition into kind of like the shortcut, the usable thing that you're gonna use today. And then we're going to do 4 examples. We're going to try and keep it moving along relatively fast. It does take a little bit of time to get through the entire thing. So we're going to dive into this, okay? There's kind of a lot of terminology in these 3 sections here, right? Chapter 9, section 1, 2, and 3. We get into what angles and standard position are. We get into these trig functions, sine, cosine, tangent, cosecant, secant, cotangent. We get into what are called coterminal angles. And then we talk about radian measures. You're going to add to your definitions today. We're going to talk about what a reference angle is, okay? So whenever it is, and I think it's going to be around next Thursday or Friday that we actually start reviewing for this quiz, you're going to find that there's just a lot to keep track of because there's a lot of material, there's a lot of just words and terms that you have to get familiar with. You have to, for instance, go into the quiz knowing the difference between a coterminal angle and a reference angle. Okay? So what we're going to do today is we're going to keep it incredibly simple. I'm not even going to give you the book definition of a reference angle. I'm going to give you your mental picture definition of what a reference angle is. Okay? A reference angle is a first quadrant angle, and then in parentheses we'll put 0 to 90 degrees because there are lots of angles that are in the first quadrant that are bigger than 90 degrees. If you start rotating a 50-degree angle over and over and over again, every time you go one full rotation, aren't you back in quadrant 1? Okay, but we're talking specifically a quadrant 1, 0 to 90 degree angle. Okay, so a first quadrant angle, 0 to 90 degrees, found only by reflection of a given angle. And just get that copied down and don't worry about it. All right, we're gonna write some stuff down here, and we're not actually gonna really make any kind of sense or understanding out of it until we actually start doing the examples. So until you get to the examples, this really isn't gonna mean too much to you. Okay, so basically here's what I got. If I give you an angle, 274 degrees. All right, 274 degrees has a reference angle. That is an angle in the first quadrant that is found by reflecting the 274 degree angle, meaning reflecting its terminal side. Don't worry about that, okay? The shortcut. All right, we can say to find, to find the reference, will be abbreviated REF, to find the reference angle for any angle theta. We'll put dot out here. All right, we're familiar with that. Yeah, you guys saw theta. Theta is just a Greek letter. We use it as an alternative to like our variables, x's and y's and stuff like that, right? Okay, here's how simple this is going to be today. If I give you an angle, like I just said, 274 degrees, or I might give you 193 degrees, or I might give you 99 degrees, or I might give you any angle on the unit circle. It could even be bigger than 360 degrees. You're going to find its reference angle, which again is a first quadrant angle by just simply doing this. It all depends on which quadrant that angle is in. So you guys remember the way the quadrants lay out, right?
1, 2, 3.
It goes 1, and then it goes counterclockwise, just like our angles do, right? A positive angle starts here and opens counterclockwise. Quadrants go that same way for that same reason. That's quadrant 2. Down here is, whoops, quadrant 3, and then quadrant 4 would be right there. Okay. Okay. If I give you a 99-degree angle, which quadrant is 99 degrees in?
The second.
The second one, it's in quadrant 2. If you want to find its first quadrant reflected angle, which is called its reference angle, here's what you do. You take 180 minus it. That's it. 180 minus 99 is 81 degrees. So the reference angle for a 99-degree angle is an 81-degree angle. It's that simple. Awesome, right? If I give you, let's not go with quadrant 2. If I give you quadrant 4, if I give you an angle in quadrant 4, let's just say 300 degrees. 300 degrees would be down here, right? All you do to find its reference angle in quadrant 1 is you take 360 minus it. So 360 minus 300 would be 60.
So do you take, like, would you have to ever take 270?
That's what you would assume, right? And I set you up for failure there. Because wouldn't we certainly assume that if in quadrant 2 you do 180 minus the angle, and in quadrant 4 you do 360 minus the angle, it just naturally holds that you would guess. The logical conjecture is to find a quadrant 3 reference angle, you do 270, right? And it's not. Actually, what you do for angles in quadrant 3 is you take the angle I give you and you subtract 180 from it. Weird, right? We look at that, we're like, yeah, I don't get it. I don't like it. Pass. Next question. Okay, so it doesn't make a whole heck of a lot of sense, but it's going to when we start getting into, and we start getting further into this, okay? Right now, all you need is this stuff wrote down. What is a reference angle from a picture standpoint? It is a first quadrant angle that you get by just doing reflection. Flipping. That's what reflection is, right? Flipping things up and down, side to side. Okay, now, how do you actually calculate the reference angles? By subtracting. Either you subtract the angle from 180, you subtract the angle from 360, or you subtract 180 from the angle, depending on which quadrant it starts in. So, here's your directions. Okay, 4 examples. The directions are going to say sketch each, and find the reference angle for each. Sketch each one, find the reference angle for each. The first part of this is what we've been doing all week, right? Even longer than that, maybe, I think, right? We've been graphing these angles. We've been sketching pictures of these angles on the coordinate plane for more than a week, haven't we? So that should be the easy part. So here's what I'm going to do. For starters, I'm going to give you a problem very similar to the one that I just got done talking about. I'm going to give you a second quadrant angle. I'm going to give you a 150-degree angle, and here's what we're going to do. We're going to draw it, and then we're going to calculate its reference angle using that shortcut thing right over here, right? This picture right here is going to show you how to do all of your very simple arithmetic today. Okay, start with a picture. Here's an x-axis, here's a y-axis. Nobody should struggle with the drawing or sketching of the angle, right? Where do you put your first ray? It's called your initial ray. Initial means first. Positive x-axis. First ray goes right there, right? And we all have, this is what we just got done talking about yesterday as we went through this worksheet, and the day before, well, not the day before that because I was gone, but the day before that, I said, you need to figure out where it goes in terms of which quadrant. Which quadrant is 150 degrees in? Quadrant 2. But what's it closer to? 180 or 90? It's closer to 180, so ooh, even that one kind of looks like it's kind of down the center. Draw it just a little bit exaggerated so that I can tell the 150 degree angle is closer to 180 than it is to 90. Make sense? What's missing from this? The direction, the curve, we call it the arc, right? You need to show me that it's the positive angle up there. It's the one that goes from the initial side counterclockwise to 150 degrees. It's not a negative angle going clockwise. Make sense? There's the easy part. The other part is also easy, right? How do you find the reference angle? You don't really even worry about what I put for the definition over here. You just literally do this. If it's in quadrant 2, how do you find its reference angle? You subtract it from 180. So literally, the reference angle, I'm going to label it RA for reference angle. Reference angle is 180 minus 150, which is 30 degrees. Anybody want to ask the question?
What quadrant is it in?
No. Most times people look at that and they say, "Is that it?" Yes.
Oh,
That's it.
Oh, that's it. Wait,
That's
but
the
don't you have to say it's in like quadrant 1 or?
No, because as soon as you say that it's the reference angle, what do I know? It should be a first quadrant. Reference angles have to be in the first quadrant, right? You're finding the first quadrant angle that goes with that is the result of just reflection. Now, I'm going to give you the mental picture here of what's actually going on. This is not going to serve you any purpose today, but it's going to help you out a little bit next week if you understand what you're actually finding when you find the reference angle. Reflection, we already talked about this. Reflecting something is when you flip it up and down or flip it side to side, right? What direction do you need to flip? Just watch this. If I were to focus on in green, you're not going to write anything down that's in green today. If you take that terminal side right there and you reflect it, what way or what direction do you have to go to get it into the first quadrant? To the right. You need to flip it side to side, right? So if you just take this and you reflect it over here, if you reflect it into the first quadrant, isn't it going to look like that? Okay, it was a 150-degree angle, which meant it was only 30 degrees up from the x-axis, right? So when you reflect this back into the first quadrant, it's still 30 degrees up, right? And when you reflect it into the first quadrant, isn't that the angle you measure? Yeah. So do you understand where it comes from or how we get the 30-degree angle? The 30-degree angle, and it's true for anything in quadrant 2, if you just take it and reflect it over here, you're going to get its same distance above the x-axis, and that distance above the x-axis in the first quadrant is how you actually measure a first quadrant angle. How you get it is you just subtract it from 180. Easy enough, yeah? Okay, let me show you another one. 4 examples, all 4 of them are necessary. All 4 of them are slightly different. I said 4 and I wrote 4. This is example 2. All right, let's go. Negative 15 degrees. Negative 15 degrees. Okay, first thing you're supposed to do is you're supposed to sketch it. So you're going to draw an x-axis, you're going to draw a y-axis, and before you do any kind of computation with numbers, all you're going to do is draw it. So how do you draw a negative 15-degree angle? Well, we always start with the same initial side, and then since it's a negative, which way do we go? Some people will say clockwise, some will just say down. You go down just a little bit because it's only negative 15, right? And then you show that it's just this little itty bitty tiny negative angle. It's going clockwise 15 degrees, so it's going down 15 degrees. 10-4, good buddies? Okay, now, for the purposes of finding its reference angle, when you find its reference angle, here's what you've got to do. You have to figure out which quadrant it's in. It's in quadrant 4, isn't it? In quadrant 4, you subtract the angle from 360, but this is the part that's kind of implied and not specifically mentioned so far. The angle you're working with has to be between 0 and 360. So, like, in order to work with this, it's got to be between 90 and 180 in quadrant 2. In quadrant 3, it's got to be between 180 and 270, and in quadrant 3, it's got to be between 270 and 360, right? Put simply, you can't find reference angles. You're not going to get an angle between 0 and 90 if you still work with this negative number. So instead what you have to do is the same thing we've been doing. You have to find its coterminal representation. How do you find negative 15's coterminal positive representation? You just add 360 to it. Negative 15 plus 360 is 345 degrees. That's the angle that you subtract from 360. Make sense? So I gave you a super simple example for the first one, positive 150. Since it was already positive and it was already between 0 and 360, you just figured out what quadrant it was in and subtracted it from the appropriate number. 150 subtracted from 180. Here, you have to get its coterminal angle between 0 and 360. So you can't use negative 15, you got to use positive 345. Once you get positive 345, all you've got to do is subtract it from 360. So to get the reference angle, it is 360 minus 345. And what's 360 minus 345? 15. Kind of makes perfect sense, doesn't it? Because think about this. Think about it from the very first definition that I gave you. If you take, don't write this, just watch. Green just means you got to watch and make sense out of it. if you were to go and take that terminal side that was rotated down 15 degrees, which direction do you have to reflect it to get it in quadrant 1? Up. If you just reflect it just a little bit up, it's going to go there, right? Well, instead of being below the x-axis by 15, now it's above the x-axis by 15, and isn't that how we measure a first quadrant angle? It's just a positive 15-degree angle. But again, it's a simple enough concept that it's not like it adds a lot of work for us to actually find its coterminal angle, subtract the coterminal angle from 360. All good in the hood? Sure. Another one. There's a good one. Everybody's happy with that one. 475 degrees. Just kidding, you don't like it. Wait. Sorry. It needs to be 575 degrees. Even worse. It smells like morel mushrooms in here. Just me? Okay. Alright, first thing we're supposed to do is we gotta sketch this. Well, what's obviously the issue with trying to sketch this?
Go around a bunch of times.
It's too big. It's gonna go. We have to know what it is between 0 and 360 to know what it actually looks like. So over here, we couldn't work with a negative angle in terms of finding a reference angle, so we had to find its positive coterminal. Well, now we're just too big. 575 is too big, so now we've got to find its smaller coterminal. So now instead of adding 360, we're just simply going to subtract 360. And like Kimmy had mentioned, when we draw it, we're going to draw our curly Q to indicate, we might as well do that right now. There's my curly Q. It's going to go around more than once because it's bigger than 360, right? How much more do I need to go? Well, that's going to be the answer given to us by our coterminal angle. 575 minus 360 is 215. Wow. Pretend that didn't make me look dumb. I had a little bit of a mental lapse there. Okay, 215 degrees. So, 215 degrees is another 180 and 15, right? No, 35. Need some lunch. We got morel mushrooms on the way. It's another 180 degrees plus 35. So 35 is going to be a little bit closer to 180 than it is down to 270, okay? So there's our whole angle, 575 degrees. It's 360 plus another 180 plus another 35 degrees down into quadrant 3. Got that? Now, here's the bonus. Not only did finding 215 degrees for the purpose of sketching our graph help us to figure out what the sketch looked like, 215 degrees is also the measure between 0 and 360 that we have to use to find its reference angle, right? To find the reference angle in quadrant 3, this is the goofy one. This is where you don't actually subtract it from anything. You subtract 180 from it. So what you actually do here, and you get the same number I just mentioned, 35 degrees, your reference angle is 215 minus 180, which is 35 degrees. It's again, in quadrant 3, you subtract 180 from it. So it's that 215 minus 180 is that 35. Now, one more time, just watch. Okay, watch what I've got here. In quadrant 3, is there a direct reflection that gets me all the way up into quadrant 1? No. You have to almost say, look, this is an extra 35 degrees right there. I already did that math in my head, right? I said it's 360, another 180 to get me all the way over here, and then another 35 to get me down to there. Well, if you take this and you reflect it up, that's also 35 degrees, right? Once you reflect it up, now what can you do with it? Reflect it over. It goes into here, and it's another 35 degrees right there. So basically, this reflection piece is going to serve a purpose when we get to next week. So right now, it's just kind of like putting this nugget of information into your brains and then kind of letting it fester. For you guys today, all you got to do is sketch the graph the same way we've been doing it for the last week, and then use the number between 0 and 360 to find its reference angle. First problem was easy. It was already 150, so we just did 180 minus 150. On the second one, we had to get 345. Then we did 360 minus 345. On this one, we needed to get 215 for the purposes of graphing. Then we did 215 minus 180 to get the reference angle. Last one. So I've already done a quadrant 2, a quadrant 3, and a quadrant 4. Here's our final example. Anybody? There you go, gosh. Oh. Mm. Yeah, I didn't tell you. Payne just figured out it's recording. Okay. Two of your problems. Your whole problem, or your whole assignment, I already put on the board here. It's 18 through 23. That's 6 questions on page 616. 4 of the problems are given in angle measures. Some are positive, some are negative, some are bigger than 360, whatever. 2 of the problems are expressed as radians, okay? You're gonna have to be able to work with radians. The good news I have for you guys today is you don't have to worry about 2 pi, okay? You're not gonna take this and you're not gonna actually deal with it in terms of pi, because here's the deal. The first thing you're supposed to do is sketch it, right? Can anybody sketch this? Myself included? No, not as it's represented, right? Not without doing the work either on paper or in my head. What I need to know what this is as an angle measure, right? So the very first thing you're going to do is you're going to convert this out of radians and into degrees. And we talked about that yesterday. We talked about it the previous 2 days. This is when you use the conversion 180 over pi. How do you know pi's got to go on the bottom? It's got to cross cancel that pi if I'm going to turn this into degrees. So the pi's cross cancel. 3 and 180 also cross simplify. They're both divisible by 3. 3 becomes 1, 180 becomes 60. So what is 7 pi over 3 in degrees? 7 times 60, which is 420 degrees. Well, I get a sense now, at least I know what I'm doing. I know I'm rotating more than 1 full time, right, when I go to sketch this? But in order to know how much more than 1 full time, what do I need to do? I need to find 420's coterminal angle. I need to subtract 360 from it. 420 minus 360 is 60 degrees. So at this point, we can finally sketch our graph, can't we? All right, here it is. There's my x-axis. There's my y-axis. My initial side goes there. My terminal side gets rotated 1 full rotation plus another 60 degrees, right? That's what a 60-degree angle looks like. So your full arc is 1 full rotation plus an extra 60 degrees. Now, think about the last piece here. We're supposed to find the reference angle. The reference angle is the first quadrant angle between 0 and 90. Well, now think about this. 420 is a first quadrant angle, isn't it? It's 1 full rotation, but then it still stays in the first quadrant. So, 420 degrees is in the first quadrant, but what does the reference angle have to be? 60 degrees. It's got to be the acute angle in the first quadrant. So you can't just say, well, 420 degrees is its own reference angle because it's already in the first quadrant. True, but technically a reference angle, not only does it have to be a first quadrant angle, it's got to be the generic one, the acute one, 0 to 90 degrees. So even though 420 ends up in the first quadrant, you still have to get its coterminal 60-degree angle because the reference angle's got to land in the first quadrant. Make sense? I'll stop the recording now. I did that on purpose.